Hey guys, today we're going to look at something called a rational function, also known as the reciprocal function. Now, a rational function is anything that is a quotient of two polynomial functions. So basically what it looks like is a fraction, where you have the numerator is some polynomial type function and the denominator is another polynomial type function. Now, the domain of all rational functions is the set of all real numbers except those values, x's, that make the denominator equal to 0. Those values of x that make the denominator equal to 0 are called excluded values, and that's because there is nothing there. So, for example, when you have a fraction, right, remember that fractions by definition are parts of a whole. You can't have a part if the denominator is 0. Like you can't have a slice of pizza out of an empty box. That's usually the analogy that I like to use when it comes to fractions. So if you ever have that the denominator is equal to 0, that means that there's nothing present on the graph. Now instead, what we have there and what you see on this graph here, this is x is equal to 0. And as you can tell, there's nothing there. There's this line that I've drawn in that doesn't really exist. And this is the function f of x is equal to 1 over x. So, like I said, the excluded values is whenever the denominator is equal to 0. So if you make x equal to 0, what you see here is this invisible line, and that's called an asymptote. And an asymptote is either a vertical, a horizontal, or a slanted line on the graph that the graph, like the actual function, so the black curves here, are constantly trying to get close to, but never actually touch. And this can go on forever and ever, and it'll infinitely get close, but never ever will it cross that line. So the domain of the function is all the numbers. So all of these negative x values, all of these positive x values, except for x is equal to 0. So the domain would be from negative infinity to 0, and I put a parentheses to not include the 0. So these are all of those negative x's. Then we start again at 0, but again I don't include it to infinity. So the domain is affected by this vertical asymptote. Now the range is affected by the horizontal asymptote, which you can see here we have this horizontal line that the graph also never touches. And this is the line y is equal to 0. So when we think about all of the y values that would be included in the range, it's all of the negative y's, all of the positive y's, except for this y is equal to 0. So the range would also be negative infinity to 0, union 0 to infinity. Now again, I mentioned the excluded values. And excluded values are the values of x that make the function not defined. Defined meaning that there's nothing on the graph. That there's something on the graph. So if it's not defined, that means there would be nothing on the graph. So in this case, since we have the vertical asymptote at x is equal to 0, that is the excluded value. So x cannot equal to 0. Now, when we look here on the graph, right, because we're going to be graphing these, we have these 2 points. We have -1, -1, and 1, 1. Those are going to be the reference points that we use when we are graphing these rational functions. Now, let's look at how to actually graph. Now, we always use rules of transformations to graph our functions. Now, the only difference here with rational functions is that you need to be able to identify what is the vertical asymptote and what is the horizontal asymptote first. So we can put that on the graph, and then we apply our rules of transformations on those 2 reference points. When we look at the equation, okay, the parent function, as you saw in the previous slide, which I'll show you one more time, is this, 1 over x. The 1 doesn't necessarily do anything for our function when we're graphing it. This is just a reminder that this is the rational function, and so our curves are going to look like that. Now over here we have 3 times 1 over x minus 1 plus 2. Our vertical asymptote is what makes the denominator is equal to 0. So if you make x minus 1 equal to 0, we have a vertical asymptote when you solve for x at x is equal to 1. Basically, whatever is down here, just switch your sign. Your horizontal asymptote is always the number that is added or subtracted at the very end of the equation. So we have this plus 2. So that means that we have a horizontal asymptote at y is equal to 2. So what we can do is we can put these asymptotes on the graph. So we have x is equal to 1, which is the vertical line that goes through x is equal to 1. And then we have y is equal to 2. Now we're going to apply our rules of transformations, keeping in mind that anything that is outside of the parentheses affects the y, and anything that is written in the denominator, since that's where the x is, affects the x. Anything outside that affects the y stays the same operation, but anything that is inside with the x will do the opposite. So when we're writing our rules, for the x's, instead of x minus 1, I'm going to use x plus 1. For the y's, we have 3 times y plus 2. So 3y plus 2. Our reference points are -1, -1, and 1, 1. And now we plug it in. When we plug in -1, -1 plus 1 is 0. Then when we plug in -1 for the y, 3 times -1 is -3, plus 2 is -1. When we plug in 1, 1, 1 plus 1 is 2. 3 times 1 is 3, plus 2 is 5. So these are my 2 points that I'm going to put on my graph here. So 0, -1, and 2, 5. Yeah. Now when you have your points, you're going to curve your function so that it never touches the horizontal and it never touches the vertical. So since the point is down here, that means my curve is going to look down, because again, it can never cross those lines. So it's going to look like this. And then on this side, it's going to curve up, again, because of those vertical and horizontal asymptotes. And that's my graph. Now, when we're writing the domain you're going to hear me say is restricted. A restriction is anything that affects your domain so that it's not -infinity to infinity. My domain is restricted by the vertical asymptote, since that is my excluded value. So my domain would be all the numbers except for x is equal to 1. So we would write -infinity to 1, union 1 to infinity. Now the range is restricted by the horizontal asymptote. So it's all the y values except for 2. So we would write the range as -infinity to 2, union 2 to infinity. Let's try that again. We have here 1 over half of x plus 3 minus 1. My vertical asymptote, remember we look here at what is added or subtracted to the x and just switch the sign. So we have a vertical asymptote at x is equal to -3. The horizontal is the number that is added or subtracted at the very end. So we have a horizontal asymptote at y is equal to -1. I can put my asymptotes on the graph. So x is equal to -3 is right here. And then y is equal to -1. Now we're going to apply our rules of transformations. Anything in the denominator affects the x and is the opposite operation. So instead of 1/2, remember that's division, so multiply 2x instead of +3, -3. Anything outside of my fraction will affect the y's. The only thing we have is this -1. So we would have y minus 1. We're going to plug in our reference points, -1, -1, and 1, 1. When we plug in -1, -1, 2 times -1 is -2. -3 is -5. And -1 minus 1 is -2. Then when we plug in 1, 1, 2 times 1 is 2, minus 3 is negative 1. And then 1 minus 1 is 0. So we can now plug in these points, negative 5, negative 2, and negative 1, 0. Now again, depending on where my points lie, that's how I'm going to curve my graph. So this is going to curve looking downwards, and this is going to curve looking upwards. Again, infinitely getting close to those asymptotes, but never quite touching. The domain is restricted by the vertical asymptote. So our domain would be negative infinity to negative 3, union negative 3 to infinity. The range is affected by the horizontal asymptote. So all numbers except for y is equal to negative 1, meaning our range would be negative infinity to negative 1, union negative 1 to infinity. Let's look at this last one here. Our vertical asymptote is going to be at x is equal to negative 1. Since remember, you can either just think about switching the sign or make this denominator equal to 0 and solving for x. A horizontal asymptote is a number that is added or subtracted at the end, so y is equal to negative 2. So I'm going to put these asymptotes on my graph. X is equal to negative 1, and y is equal to negative 2. Now we're going to apply our rules of transformations. So xy. Our rule for the x's, the only thing in the denominator is x plus 1. So we're going to use x minus 1. Anything outside of these parentheses and outside of my fraction affects the y's. So negative 3y minus 2. Now we plug in our reference points. When we plug in negative 1 minus 1 is negative 2. And when we plug in negative 1 for the y, negative 3 times negative 1 is positive 3, and positive 3 minus 2 is 1. Now when we plug in 1, 1 minus 1 is 0, negative 3 times 1 is negative 3, minus 2 is negative 5. So I'm going to plot these points now, negative 2, 1, and 0, negative 5. And now we graph our curve based on those vertical asymptotes and horizontal asymptotes. So this side is going to curve up, and this side is going to curve down. And you can always use your transformations to double check if you did this correctly. Based on my transformations, I have this negative, meaning that there was a reflection over the x-axis. Now, our original function, as you can see, I'm going to go back to the beginning a moment. We have on the left side curving down and on the right side curving up. So if it was reflected over the x-axis, then the left side would curve up and the right side would curve down, which is what we see here. Then there was a vertical stretch of 3, which normally the reference points would be 1 unit across here, like 1 unit to the left and up from the asymptotes. And so when we see here, it was 1 unit to the left, but it was 3 units up, and that's because there was a vertical stretch. Then it was shifted to the left 1, that's why our asymptote is to the left 1, and then this was shifted down 2, so that's why the horizontal is down 2. So you can use what you know about transformations to help you make sure that your graph is correct. Now your domain. The domain of this graph is restricted by this vertical asymptote. So all real numbers except for x is equal to negative 1. So my domain would be negative infinity to negative 1, union negative 1 to infinity. Our range is restricted by the horizontal asymptote. So it's all real numbers except for negative 2. So negative infinity to negative 2, union negative 2 to infinity. Now we're going to look at when function is not necessarily written in transformation form where I can tell what the transformations are. So for example, here we have g of x is equal to 3x minus 4 over x minus 1. It's very difficult for me to tell what my transformations are if it's written in this way. So in order to graph this function, we are going to rewrite it so that I can see what those transformations are. Now, a fraction is essentially division. So in order to do that, what we have to do is divide the numerator by the denominator. So we have here 3x minus 4 divided by x minus 1. So we're doing long division here. In order to get 3x, I would need to multiply x by 3. And then we distribute. 3 times x is 3x. 3 times negative 1 is minus 3. Then we change the signs. And hopefully you remember this from our previous unit. So we can cancel out these 3 x's, and then negative 4 plus 3 is negative 1. Now, how does this work? When we rewrite this and how we learned how to write our answers from long division, we write the quotient, which is 3, and then we add the remainder, which in this case is negative 1, so I'm going to subtract 1, and we put it over what we divided by, which is x minus 1. Now this is almost in transformation form, but we know it with the number at the end, the whole number, so we're just going to flip it. So instead of 3 minus 1 over x minus 1, we would write negative 1 over x minus 1 plus 3. Another trick is whatever is in the numerator. If it is not just 1, you're going to factor out whatever number or sign is attached to it. So this is equal to negative 1 over x minus 1 plus 3. This is now in transformation form, and I can tell exactly what the rule I would use to write, to be able to graph. So whatever is in the numerator, if it's not just 1, just take it out and put it outside of the parentheses. So this was negative 1, so I took out the negative. So that way I can see exactly how I'm supposed to write out my transformations. Now for the rule for my x's here, we have x minus 1. So my rule would be x plus 1. Now for the y's, we have a negative on the outside and then the plus 3. So negative y plus 3. Plug in our reference points. When we plug in negative 1, we get negative 1 plus 1, which is 0. Then negative 1 will make this positive 1, plus 3 is 4. When we plug in 1 plus 1 is 2. Then here when we plug in 1, we have the negative, so negative 1 plus 3 is 2. So we have our 2 points that we can plot. Now, before I plot, I'm going to also get my vertical and my horizontal asymptotes. My vertical asymptote is that x is equal to 1. And my horizontal asymptote is that plus 3 at the end, so y is equal to 3. I'm going to go ahead and sketch these asymptotes just like we've been doing. We have x is equal to 1 and y is equal to 3. And then I'm going to plot my points. We have 0, 4 and 2, 2. So based on where my points are, I can now curve my graph. And this will be my function. Now for the domain and range. Again, the domain is restricted by this vertical asymptote. So my domain would be negative infinity to 1, union 1 to infinity. And my range is restricted by the horizontal asymptote. So my range would be negative infinity to 3, union 3 to infinity. Let's try a couple more examples. We have here negative x minus 1 over x minus 3. First, we are going to rewrite the function by dividing. So remember, you are dividing the numerator by the denominator. So that means the denominator goes on the outside and the numerator goes on the inside of my division symbol. And then we look at the first terms. In order to get negative x, I would have to multiply x by negative 1. And then we distribute. Negative 1 times x is negative x, and negative 1 times negative 3 is positive 3. Now we switch the signs, and we get negative 4. Now here's a little trick if you want to do this a little bit easier. Whatever you have here, that's going to go on the outside. Open parentheses. You put 1 over what we divided by. And then add what you got here as your answer, minus 1. So this will always work. If this doesn't really make much sense to you, you can go through your process. The answer, typically what we know, is negative 1, and then we would add the remainder, so minus 4 over x minus 3. Reverse the order. So this is negative 4 over x minus 3 minus 1. And then take out whatever is in the numerator. So we can move the negative 4 to the outside, like right here, and then put 1 over x minus 3, and then the minus 1. So whichever way you prefer to do this. Now we can figure out what is the vertical asymptote and what is the horizontal asymptote. The vertical asymptote is anything that makes the denominator equal to 0, so just switch your sign there. So x is equal to 3. And our horizontal would be y is equal to negative 1, the number that is subtracted here at the end. So we can put those asymptotes on our graph. X is equal to 3, and y is equal to negative 1. Now we're going to create our transformation rules. According to my function here, the rule for the x would be x plus 3. And the rule for the y's would be negative 4y minus 1. Now we plug in those reference points. When we plug in negative 1, negative 1 plus 3 is 2. Negative 4 times negative 1 is 4. Minus 1 is 3. And when we plug in 1, 1 plus 3 is 4. Negative 4 times 1 is negative 4. Minus 1 is negative 5. So now I'm going to plot these points. So 2, 3, and 4, negative 5. And based on where my points lie, I can graph my function. Now the domain and range. Once more, my domain is restricted by my vertical asymptote. So my domain would be negative infinity to 3, union 3 to infinity. My range is restricted by the horizontal asymptote. So my range would be negative infinity to negative 1, union negative 1 to infinity. Let's look at this last one here. We have 3x plus 8 over x plus 2. So I'm going to divide 3x plus 8 by x plus 2. In order to get 3x, I would have to multiply x by 3. Distribute the 3, we get 3x plus 6. Switch the signs. The 3x's cancel, and 8 minus 6 is 2. So my answer here, if you do it going through your process, would be 3 plus 2 over x plus 2, which then I can reverse the order. So 2 over x plus 2 plus 3. Anything that is in the numerator, I can factor out. So we would write 2 parentheses 1 over x plus 2 plus 3. From here, now I'm able to find my asymptotes. The vertical asymptote in the denominator, we see that it's x plus 2, so we have a vertical asymptote at x equals negative 2. The horizontal is the number added here at the end, so y is equal to 3. So I can now put those asymptotes on my graph. we have x is equal to -2 and y is equal to 3. Now we're going to write our rule of transformations. The rule for the x's would be x minus 2. And the rule for the y's would be 2y plus 3. Use our reference points, -1, -1, and 1, 1. When we plug in -1, -1, -1 minus 2 is -3. 2 times -1 is -2, plus 3 is 1. When we plug in 1, 1, 1 minus 2 is -1. 2 times 1 is 2, plus 3 is 5. So we can now plot these points, -3, 1, and -1, 5. And now we curve. So this would be my graph. Now for the domain. The domain restricted by the vertical asymptote. So our domain here would be -infinity to -2, union -2 to infinity. The range is going to be restricted by my horizontal asymptote. So -infinity to 3, union 3 to infinity. Now we're going to switch gears a little bit, and we're going to work backwards. So now I'm going to actually give you the graph, and you have to write the equation. And here I have steps on how to do this. The first thing is to find the values of the parameters h and k. The parameters are just these values here, meaning what's affecting your function. H represents the value of the vertical asymptote, and k represents the value of the horizontal asymptote. Here on the graph, we can see that we have a vertical asymptote at x is equal to 3. If you're ever not sure how to write the equation of a vertical asymptote or a horizontal asymptote, these are lines, right? You just got to look at what axis the line crosses. A vertical line crosses the x-axis, and that's why the equation is written as x equals 3. A horizontal line crosses the y-axis, so this horizontal line would be y equals, and it crosses at 4. So that means that h is 3 and y is 4. K is 4. So now what we're going to do is we're going to take our equation here, g of x is equal to a parentheses 1 over x minus h, which is 3, so x minus 3, plus k, which is 4. Now, the only thing that I need in order to write this equation is the value of a. And in order to find this value, you're going to pick a point, whichever point you'd like. Let's say that I pick 4, 6. So I'm going to plug in 4 for the x and 6 for the y, which is also g of x. So my equation would be 6 is equal to a parentheses 1 over 4 minus 3 plus 4. This gives me 6 is equal to a times, now here we have 1 over 4 minus 3, which is 1. And 1 over 1 is just 1, plus 4. To solve for a, we would subtract the 4. And we get 6 minus 4, which is 2, is equal to a times 1, which is just a. So a is 2, which is what I needed. So now the equation for this graph is g of x equals 2 parentheses 1 over x minus 3 plus 4. Let's try that again. Here we have this graph. We have a vertical asymptote here located at x is equal to -3. Then we have our horizontal asymptote at y is equal to -1. So again, this is the format for my equation, so I'm just going to write it out. We have g of x is equal to a parentheses 1 over x minus negative 3, so that's x plus 3, minus 1. To solve for a, I pick a point. Does not matter which point you choose. Let's say I choose this one here. So I'm going to plug in negative 5 for x and 0 for g of x. So 0 is equal to a parentheses 1 over negative 5 plus 3 minus 1. If we work this out, we get 0 is equal to a times 1 over negative 5 plus 3 is 1 over negative 2 minus 1. Add the 1 to both sides. We get 1 is equal to a times 1 over negative 2. To cancel this out, we're going to multiply by the denominator, which is negative 2. And we get that a is equal to negative 2. So my equation would be g of x is equal to negative 2 parentheses 1 over x plus 3 minus 1. And this would be my answer. Last one here. We have our vertical asymptote at x is equal to 2. And we have our horizontal asymptote at y is equal to 1. So we're going to write out the equation so far. We have g of x is equal to a parentheses 1 over x minus h, which is 2, plus k, which is 1. Pick a point, does not matter which one. I'm going to choose this one. So I'm going to plug in x is equal to 4 and g of x for 3. So we have 3 is equal to a parentheses 1 over 4 minus 2 plus 1. We can subtract this 1 and we get 2 is equal to a times 1 over 4 minus 2, which is 2. To cancel this out, we're going to multiply 2 to both sides. And we get that 4 is equal to a. So now I can rewrite my equation. So g of x is equal to 4 parentheses 1 over x minus 2 plus 1. And that would be my answer. And that's graphing simple rational functions.